So let's remind ourselves of a few of the properties that were used prior to going on break. So the first property was changing a logarithmic equation to an exponential equation. So you have something in logarithmic form. You have your base, you have your y component, you have the x, and you simply rewrite it as an exponential equation. That was first and foremost. For your basic properties, if you have a log and both bases match, the answer is 1. If you have a log, you have matching bases with an exponent, then the exponent is the answer. If you have a log with a base, if the next number is 1, then the answer is 0. And those are your basic properties of logs. As far as the algebraic properties are concerned, if you have a log with two things being multiplied, you separate them by adding. If you have a log with two things being divided, you separate them by subtraction. If you have a log of something raised to an exponent, move the exponent out in front, and you multiply times the log. So prior to us going on break, we did the basic rewriting, and we worked with the properties themselves. Rewriting, working with the properties. So, any questions before we move on? All right. So there's one other property that exists that allows us to use the calculator. Now, all calculators are programmed to work with base 10. All calculators are automatically set to base 10. So remember, base 10 is the standard base. So if they give you log of a number, that's automatically log base 10 of that number. But our calculator is automatically set up to handle it. So you have log 56. Go to our next calculator. Log 56. Close the parentheses. So you have 1.748. So we always round to 3 decimal places unless they tell us otherwise. So 748. You have a 1 sitting behind 8. That 1 wouldn't do anything. That's 1.748. How do you know where to round? You read the directions. If the directions don't give you, then you round to 3 decimal places. So it's 3 decimal places, unless the directions tell you otherwise. And one more basic example, log 3.8. First log 3.8, close your parentheses. 0.5797. So again, you go to 3 decimal places, unless told otherwise. So 5797. So that 7 is going to force the 9 to move up to the next number. So your rounded answer .580. 4.58. So if you forgot how to round, you need to relearn how to round. Any questions before we use change of base? So let's use some change of base. So change of base formula allows you to use the calculator regardless of what the base is. So the base could be 2, 80, a million. 1/2. It can be anything you want, as long as you know how to rewrite the problem. So you have log base b, and then another number a. So you would rewrite it as log of a divided by log of b. So you rewrite it first, and then you let the calculator do its work. Once you rewrite it, it automatically transforms to base 10. It's like magic. So example 3. Log base 3, 28. So 3 is your base, and 28 is your A value. So first we do the rewrite. So 28 is the A value. So log 28 over log 30. Log 28 over log 30. Any questions before we continue? Because now we're going to let the calculator do the rest of the work. So let's let the calculator do the rest of the work. So you have log 28 divided by log of 3. Log 28, close the parentheses, divided by log 3. Close the parentheses. So you have 3.033. There's a 1 behind it, but that doesn't change. 3.033. That's it. Time to go. Now, let me address these two things because it is very easy for some people to get lazy doing this type of problem. Notice that I open the parentheses, close the parentheses. Do not get lazy solving the problem. For example, suppose you don't close that parentheses. There's your answer. That doesn't match up. So if you choose to do it that way, guess what? You're setting yourself up to get the wrong answer. Well, Mr. Hall, do I have to put log twice? Okay. Don't put log twice. There you go. Again, that's not the right answer. The moral of this story is very simple. Stop being lazy with it. Don't be lazy with it. Do the problem the right way. Just like my mama said, you either have time to do it right or you have time to do it over. Do it right the first time. Any questions? Example 3. It's not that hard of a problem. Don't make it harder than it is. So let's do another. Log base 6, 4/5. This is low, it's fraction. So, this is your base. The fraction in the A value. Same with the 5. Log 4/5. Log 6. Once you do the rewrite, then we can make the calculator do the rest of the work. Log 4/5 divided by log 6. Can you get a negative answer? Yes. So you get negative answers for your homework, quiz, test, final, whatever the case may be. Don't be freaking out. As long as you set up the problem the correct way and you didn't mishit anything, then you're fine. Negative 0.124, there's a 5 behind it. Negative 0.125. Any questions, examples 3 or 4? All right. What we get? What number we get? Yep. And anyone object? Any objections? Good. You shouldn't. That's right. 3.088. If you have 3.087, that means you didn't round it correctly. So the setup is log of 12 over log of the square root of 5. Now, some people might have had trouble with putting it in the calculator. Let's take care of that. So log 12, close parentheses, divided by log square root 5. Now, I have a newer model calculator, so I got to use the arrow key at the top to move it to the right so I can close my parentheses. So since I have a newer model calculator, I have to do that extra step. But if I have an older model graphing calculator, so when you change this calculator to the older model, log 12 divided by log square root. So for the older style calculators, once you open a square root, it's going to put another parentheses. Put your 5 in there, close the first parentheses, close the first parentheses for the square root, close parentheses again to take care of the log. It might not make a difference, but that's just to be on the safe side. So the last parentheses might not make a difference, but that's just to be safe. But sure enough, you should get these in the same answer. Any questions? Change of base. So now there are no restrictions on what kind of logs we can work with. If you can't rewrite it, then we got to change the base to solve out the problem. We have zero restrictions now. So now that we have zero restrictions, let's start solving equations. So there are quite a few different types of solving equations. We're only going to deal with examples 6 and 7 today. And we'll work with the rest of them on tomorrow. Ooh, I hear rumbles and thunder. I'm happy that I already taught this lesson first period. So, example 6. We have 6 to the x power equals 40. So if you think back to when we started exponential equations, if we could rewrite these with the same base, then we're good to go. But there's no way you can rewrite 40 as 6 raised to some power. It's not going to work. 6 to the second power is 36. That's not big enough. 6 to the third power is 216. That's too big. So you can't rewrite it that way. So in order to solve the equation like that, we're going to first rewrite it as a logarithmic equation. So rewrite as a log. There's your base, there's your exponent, there's your y. So log base 6, 40 equals x. The first step, rewrite it as a log. So log base 6 of 40, that's just a number. So now we use change of base. Now we use change of base. Log of 40 over log of 6. Log of 40 over log of 6. Let the calculator do a little bit of work. 2.0588, so that becomes 2.059. And that's your final answer. That's it, problem over. He was expecting it for it to be harder than that. I'm sorry. So in case you're wondering, you do not have to worry about checking the answer because they're exponential equations. Exponential equations will always work out. If it started off as a log, then you would have to go back and check. Exponential equations are good to go. Any questions? Example 6. before we finish this off with example 7. We'll call this one. All right, so example 7. Example 7 is no different than example 6. We follow the same 7. There's no way that you can write 33 as 5 to some power. So we're going to rewrite it as a logarithm. Log base 5, 33 equals 4n. So rewrite to a log. The left-hand side is nothing but a number. Use change of base. Because I know someone is going to ask, what is called being, Mr. Lowe? Change of base. Log of 33 and log of 5. So again, we let the calculator do a little bit of work. Log 33 divided by log 5. That'll give you 2.173 equals 4n. So the only difference is that now you have a number in front of the variable. You can easily take care of that. Divide by 4. And you end up with 0.543. Again, you were expecting that to be harder than what it was. I'm sorry. As long as you know the properties, it's not that hard. Any questions? 6 or 7? Sounds music. Sounds like everyone's in a good spot. So, we picked up change of base, and we've been able to use it as another way to solve equations. So tomorrow, of course, we'll finish off the other 5 examples that we have, and that will finish up section 7.6. So, stop.